So now we will practice using the sum to product formulas. In example 6, the directions say to express each expression as a product of trigonometric functions. Again, when this type of wording is mixed up on an exam or a quiz, you have to recognize that you're being asked to convert or to use the sum to product formulas. Okay, you are given a difference in part A, okay, and you're asked to convert that to a product, okay. So the key here is basically changing this over to a product, and that should signal that you need to use a sum to product formula, okay. Again, just like when we did some practice with converting products to sums, your answer will not be just a number. It is going to be a full expression, okay? So just remember that. All right, so like I said, in part A, we have the cosine of 4x minus the cosine of 2x. This is a difference, and we need to change it over to something times something. Okay, so we need to go back to the sum to product formulas, and we need to scan them for the appropriate formula. Okay, we have cosine minus cosine. Okay, so make sure you realize there's a separate formula for cosine plus cosine and cosine minus cosine. So what we have is matching up with this last formula. So I'm going to go and write that down because that is what we are going to use. Okay, we know that the cosine of A minus the cosine of B is equal to -2 times the sine of A plus B divided by 2 times the sine of A minus B divided by 2. Okay, so now we need to match up our expression with the left side of this identity. Okay, we are working with the cosine of 4x minus the cosine of 2x. Okay, so I see a match with the first cosine, okay, and I see a match with the second cosine, and there's a minus in the middle, okay. The first cosine's argument is 4x, so that's going to tell us that the A value here is 4x. And then if we look at the second cosine, its argument is 2x, so the B value here is going to be 2x. All right, there isn't any number out front, so we don't have to adjust for that. We pretty much have an exact match, so we can just plug into the right side of the identity accordingly. Okay, so the cosine of 4x minus the cosine of 2x is going to be equal to -2 times, let me use a different color, this is going to be -2 times the sine of the A value, so 4x plus the B value, 2x, all of that is divided by 2, okay, times the sine of A, which is 4x, minus B, which is 2x, all divided by 2. Okay, so now we just simplify and we're done. Okay, so this is going to be equal to -2 times the sine of 4x plus 2x is 6x divided by 2 times the sine of 4x minus 2x is 2x. That's divided by 2. So we can cancel, we can divide by 2 in both of the arguments. So the final answer is -2 times the sine of 3x times the sine of x. Okay, and you can write it without the parentheses, that's fine. This is going to be -2 sine 3x times sine x. Okay, all right, that's the final answer. You can see the answer is in expression. Okay, we weren't going to get a number as the final answer anyway because we have an x involved, but the expression that we did end up with is a product. Okay, we're multiplying everything together. Okay, so we converted the difference to a product. Okay, let's try the next one. Okay, in part B, there is no variable. Okay, so you just have numbers, but again, same thing. You need to take this expression that is a sum and you need to convert it to a product. Okay, so here we go. So we have the sine of 25 degrees plus the sine of -48 degrees. Okay, this is a sum and we need to convert it to a product. Okay, so we need to go and scan our sum to product formulas and figure out which one matches up. Here we have a sine plus a sine. However, before we do that, one of the arguments here is negative. We have negative 48 degrees. So I want to address that first, okay? Sine is an odd function, so that negative sign can come out, okay? So this is actually equal to the sine of 25 degrees minus the sine of 48 degrees, okay? So I'm actually going to use the formula for sine minus sine, okay? If you didn't do this and you proceeded using the sine plus sine formula, that's okay. It would have worked its way out eventually because you would have just applied the formula with a negative argument, and then you could have adjusted for that at the end, okay? But here I'm trying to make it easier by dealing with the negative argument first, okay? But it should work out either way. All right, so I'm going to go and get the formula for sine minus sine. Okay, if I go back to page 9 and I look at my sum to product formulas, sine minus sine is formula 11. I'm going to use this guy. Okay, so let me go jot that down. I know that the sine of A minus the sine of B is equal to 2 times the cosine of A plus B over 2 times the sine of A minus B over 2. Okay? All right, so I need to match up my expression with the left side of this identity. Okay? I am working with the sine of 25 degrees minus the sine of 48 degrees. Okay, this one matches up extremely easily, okay, because I have sine, I've got the minus, the sine, and the sine, and you can see here that A is going to be 25 degrees. It's the argument of the sine on the left, and then B is going to be 48. It's the argument of the sine on the right, okay, so here we go. There's no numbers to adjust, okay? It matches up perfectly, okay? So the sine of 25 degrees minus the sine of 48 degrees, just follow the recipe given by the red identity. This is going to be 2 times the cosine of A, which is 25 degrees, plus B, which is 48 degrees, all divided by 2, times the sine of A, which is 25 degrees, minus B, which is 48 degrees, all divided by 2. Okay, so now we just need to simplify this and we will be done. Okay, so we're going to get 2 times the cosine of all this stuff. So I need to go figure out what my argument is. So I'm going to go to my calculator. This is going to be 25 plus 48. That's the numerator. So I'm going to have 73 degrees divided by 2. Okay, times the sine of 25 minus 48. Okay, so that's going to be negative 23 degrees divided by 2. Okay, so now I'm going to keep simplifying here. I'm going to leave the 2 out front, and then as far as the arguments go, we have a degree measure divided by 2. I'm just going to convert them over to decimals. Like if I do 73 divided by 2, I'm going to get 36.5. So I'm going to say this is 36.5 degrees. That's what I'm taking the cosine of, because when you're taking the cosine of that argument, that degree measure is what's being divided by 2. So you can go ahead and half the degree measure to make it 36.5. Okay, so the sine value, I can do the same thing. I can take the 23 degrees and divide it by 2. So I'm taking the sine of 11.5 degrees. Okay, and we have a negative argument here, but remember, sine is odd, so we can take the negative out. Okay, so really the negative sign would go in front, so it would be negative sine. So since we're multiplying here, okay, that negative can go in front. Okay, so this is going to be the final answer. Okay, I am not going to go and compute the cosine of 36.5 and the sine of 11.5 degrees. I'm not doing that, okay? I don't want a final answer. I don't want a final number. I don't want a number as the final answer. Remember, we're just trying to convert what we were given as a sum. We were trying to convert this to a product, and we have that here. The answer is -2 times the cosine of 36.5 degrees times the sine of 11.5 degrees. Okay, leave it alone. Okay, let's try one more here in part C. Now we have the sum cosine of 5x plus the cosine of 8x. Okay, we've got to change this over to a product. Okay, we won't get a number as the final answer anyway here because we have a variable. Okay, so we have cosine plus cosine. We need to go figure out what to use. If we scan this list, this is going to be formula number 12. This is cosine plus cosine. I'm going to jot it down. We know that the cosine of A plus the cosine of B is equal to 2 times the cosine of A plus B over 2 times the cosine of A minus B over 2. Okay, so we just need to match up our expression with this identity. Okay, on the left side, okay, I'm comparing that to what I have, cosine of 5x plus cosine of 8x. Okay, so this is great. These in general, you can see these sum to product formulas generally match up really nice with the identity themselves. Okay, so I've got a cosine, cosine, I've got a second cosine, cosine. So again, matching up really nice. We've got the plus signs in the middle. So here it's pretty obvious that A is 5x, B is 8x. Okay, so we're just going to apply, there are no numbers to adjust for. We can just go ahead and figure out what our expression equals according to the recipe given by the right side of the red identity. Okay, so this is going to be 2 times the cosine of A plus B over 2, so that's going to be 5x plus 8x over 2 times the cosine of A minus B over 2, so that'll be 5x minus 8x over 2. Okay, so now we just simplify the arguments. This is going to be 2 times the cosine of 13x over 2 times the cosine of negative 3x over 2. So let me fix that really quick. All right, so we can leave it like this in terms of fractions versus decimals, or you can convert them to, you can leave them as fractions or you can convert them to decimals, okay? So the other thing I need to address is this negative sign, okay, inside the cosine argument on the right here. So we've got the cosine of negative 3x over 2. So cosine is even. So remember, for an even function, the negative gets absorbed. Okay, so this is going to be the same thing as 2 times the cosine of 13x over 2 times the cosine of positive 3x over 2. Okay, so that is a final answer, or I can convert this. I can convert the fractions to decimals. If I do 13 divided by 2, that is going to be 6.5. Okay, so I could put 6.5x. Well, hang on, let me just write it this way. This could be 6.5x that I'm taking the cosine of. Let me try this one more time. Times the cosine of 3/2 is 1.5 times x. Okay, remember, you cannot combine these cosine pieces. Okay, cosine of 6.5x times cosine of 1.5x, you can't combine them. Okay, you can't like do cosine squared and then multiply the arguments. That is not allowed. Okay, so you're just going to have to leave the answer like this. Okay, and I will box both versions here. Okay, with fractions or with decimals. Okay, we have taken our original expression, which was a sum, and now we have our answer. We've converted it into an expression where it's something times something. It's cosine times cosine. Okay, so we are done.